Board. All right, class, today we're going to talk about parallel and perpendicular lines. A very exciting topic. See the exclamation point? Woohoo! Woohoo! First thing we're going to look at is we're going to look at these two graphs. We see 4 different lines on them. You'll be able to notice parallel lines. You'll also be able to see the perpendicular. But what I want you to know is not only look at the lines on the graph to see which ones are parallel, but I want you to be able to recognize lines if they're parallel or perpendicular based on the equation that you use to graph those lines. So let's do some comparisons. What do we notice? We can spot that our A and B are parallel on both of our graphs. What do we notice about their equations? We should notice that our slope in each of these two equations, A and B, are equal. So if these two lines are parallel, what do we know that makes these lines parallel? The same slope. Identical. We also notice that, or should notice that, if we're going to compare our parallel lines, A and B, to our perpendicular line, which is C, let's compare those slopes and see what's different about them. So here we have 2 or 3 halves, and our slope for C looks like it's flipped from 3 halves to 2/3 to also being opposite. One's positive and one's negative. So that's what we should notice about perpendicular slopes. Here we have 2 flipped. The reciprocal is 1/2. The first one's positive, the next one's negative. If you compare A, B, and C, and D, you notice that D looks like it could be perpendicular, but it's not the opposite. So it has to be flipped and opposite. It has to be both. And what we like to refer to that in my class are flipped opposites, flopposites. So whenever you're finding perpendicular slopes, look for the flopposites. So we're going to do 3 different types of examples of problems you're going to be seeing tonight on your homework. The first is you're going to be given 2 points and an equation of a line. You're going to find the slope, and then you're going to name a line that is parallel to that slope and given a slope that is perpendicular to the given one. So let's start. We already know how to find a slope given 2 points. We use our slope formula. Remember, it's y2 minus y1 over x2 minus x1. So we take 4 minus 0 over negative 2 minus 2. We'll go ahead and solve and find what that slope is. It's 4 over negative 4, which we can go ahead and reduce to negative 1. Now, the symbol, mathematical symbol for parallel, are these train track looking lines kind of at a slant, an equal sign at a slant, slanted upwards. So our parallel line to this first example A is negative 1, because parallel lines have the same slope. We want also a perpendicular slope. Perpendicular symbol looks like a right angle, the little box. So a perpendicular slope to this is going to be flipped opposites. So the opposite of a negative 1 is positive 1, and 1 over 1 is just going to be 1 over 1. Now the second example on this one, you're given an equation of a line. Before you can look at this and determine what the slope is, you need to put it in slope-intercept form. So let's go ahead and rearrange these, manipulate it so it's in the form of y equals mx plus b. Whoop. So we want to move the 3x to the other side, so we're going to do that by subtraction. So subtract 3x from both sides. We're left with 4y, because those are going to cancel out, equals negative 3x plus 5. And we need to get the y by itself, so we're going to divide both sides by 4. So our equation for this line is y equals negative 3/4 x plus 5/4. So what we're really interested in when we change this around to slope of intercept form is the slope. So I have negative 3/4. So our parallel slope to this line is going to be negative 3/4. And our perpendicular slope is going to be flipped opposites. Flopposite is 4/3. So that's what you need to do. If you're finding a slope of a line that's parallel or perpendicular to a given. Next, this time, instead of giving you one and telling you to name both parallel and perpendicular slopes to that one, they're going to give you two slopes, and then you need to determine by comparing the two slopes, are they the same, which would be parallel? Are they flopposites, perpendicular? Or are they neither parallel or perpendicular? Are they like lines A to D? So in this case, let's go ahead and solve. So we have our 6 minus 0 over 2 minus negative 1. So we have 6/3 reduce 2. Solve our other one. 0 minus 2 over 3 minus 4. We get negative 2 over negative 1, which when you have a negative over negative, they cancel each other. 2. Compare the two slopes. 2 is the same as 2, so these two sets of points are going to be parallel. And you can write the symbol if you're lazy, or you can go ahead and spell out the word parallel. Now the second one, this one, you're given equations for the lines. So in this one you need to make sure they're in slope-intercept form. This one, all we need to do is divide by 3. We get y equals negative 5/3 x plus 7/3. And here our slope, remember this is one of our special lines, y equals 3. So the slope here is 0. So if we compare negative 5/3 and 0, they're not the same, they're not flopposites, so these have a neither. These lines are neither parallel or perpendicular. And then, just to refresh, parallel lines have the same slope. Vertical lines are parallel and have slopes that are undefined. So if you've got a graph and you've got two lines that have undefined slopes, those lines are parallel that way. Perpendicular lines are negative reciprocals, flipped opposites. So we've already done A, B, and C. We've done examples like this, and we're done. Done.